Okay, so two terms that sometimes are used interchangeably, but they mean something a little bit different, are parabolas and quadratics. A parabola is the shape of a quadratic graph. I've drawn this little upside down U shape and this U shape over here, but let me flip over here to Desmos and actually just graph it so you guys can see perfectly what it looks like. There is what a parabola looks like. So it's this sort of U-shaped graph that you'll see. It's just what you get when you square a number. So like if I square 0, 0 squared is 0. 1 squared is 1. What's 2 squared? 4. What's 3 squared? 9. So you can see these popping up here. Let me make this shape a little bit bigger. Right. You also could, on the negative side, negative 1 squared would be 1. Negative 2 squared would be 4. Negative 3 squared would be 9. So you can just see, and you could continue this on out if you keep on going. You know, if I take 4 squared, it's 16. And so whenever you square a value, it creates sort of this U shape like that. So these are going to be something that we're going to find that are very useful for doing several different types of applications. One of the main things that we're going to look at for applications is called projectile motion, which we're not working on today. Today we're like just working on basics of how to deal with these. But just to give you a picture of like where you're going to use all this stuff one day, or possibly. Remember, I've told you guys already, you're kind of like beyond the everybody needs this to survive in their life sort of stuff. But if, for example, if I go out here and open the window, and let's say we're about 12 feet above the ground, and I throw a ball up into the air, right? So the acceleration due to gravity is negative 16x squared. Let's say I throw it with an initial upward velocity of 20 feet per second, and then we are 12 feet off of the ground. Let's say that's the case. So if let me do this. Let's go from 0 to 2. You can use calculus to analyze some of this, but it's not, and it's not going to be all that like crazy difficult. So like if I had this situation, we'll look at it in more depth because I'm just trying to give you sort of a preview of where this would possibly apply. So this makes sort of that same shape I was just showing you with x squared, right? It's a lot different because it's been flipped upside down and it's been stretched out and moved and all kinds of stuff like that, but it makes that same general shape. This is the general shape that you're going to see the height of something follow whenever you have something that is either dropped or thrown into the air. So this gives us a lot of good information. So like if I knew these pieces of information, I could tell you that it'll take 1.693 seconds for that ball to hit the ground. I could also tell you that its maximum height would be 18.25 feet. I could also tell you that if, let's say that if Evan is standing out there and Evan is we'll do 5.9 feet tall, then I can tell you if he is standing out there that it'll take 1.5036 seconds till he gets hit in the head by this ball that I have thrown, if he is in that line of that path. So if he sees me throw the ball at him with my deadly accuracy, he will have 1.5 seconds to dodge the ball before it actually gets there. So he's probably in pretty good shape there. Oh, I probably have terrible accuracy in reality here. So there's a lot of cool stuff that you can do with this. This is where we're going to use our catapults because we're going to sort of analyze that. But before we're able to do any of that, we have to look at just sort of the raw graphs and know how to deal with those. So that is what we are going to be doing first today and probably tomorrow a lot too. And then we'll start into some of like this application stuff where we can kind of figure out some kind of cool stuff. You're also starting to here look at sort of some higher level math that definitely is not something just everybody is going to use in their daily life necessarily. I know some of you are like, ugh, that sounds terrible. Why am I learning it if I'm not going to use it in my daily life? But I think it's really cool to have just at least the basis knowledge of sort of like higher level stuff. So whenever you're looking at, I mean, basically what I was just showing you there is physics. So if you were designing some sort of something, a catapult, something there, you would take a lot of the stuff into consideration. So I think it's kind of neat. The word quadratic refers to the expression itself. So that is what we use to talk about the equation there. I did the other day, I think I told you guys whenever we started, I never really understood why the word why they used quad for quadratic whenever it's to the second power instead of to the fourth power, because normally quad means 4. And I realized, because I have this little book at home that has a lot of like math stuff in it that I sometimes will read, just like it's almost like a coffee table book. It's just got like these little short topics, and you can read like a page or something or two out of it. And so anyway, I read the page the other day on quadratics, and it said that the word quadratic comes from a Latin word that I can't remember, but it started with quad, because in Latin that meant that would be squared. But of course, when it's translated to English, we typically use quad for 4, so that's why it's quad instead. So it's a question I've had for a long time, and I finally found the answer to it. So this refers to the actual expression. All right, so we're going to start first with a y-intercept. So y-intercept is where we cross the y-axis. Okay. If we think about graphing just a parabola, I'm just going to throw a few up here. I could have a parabola that looks maybe something like this. You can if you want. And so right here, this would be my y-intercept. What are the coordinates of that point? 0, 10. Okay. If I do another one, I might have something that looks like this. Okay. Here is my y-intercept. What are the coordinates of that point? 0, -2. I might have a third one that looks maybe something like this. You can have one that is sideways, but in order for that to be the case, the x's and y's have to be flipped. It has to be like x equals y squared plus 3y minus 4, and that is something that you don't come across until pre-calculus. So it can be that way, but you will not see anything where they're sideways. And so like right here, we will have 0, 4. What do you see in common with all those y-intercepts? Caitlin, surely you don't have a phone back there, do you? Okay. All right. These happen to be even numbers. What else do you see? All the x's are 0 for this. I happen to pick even numbers, which is also true for this, but they could be odd. The x's are all 0. So to find a y-intercept for an equation, and this is true for all equations, not just for quadratics. Okay, so this is true for lines, it's true for exponentials, it's true for all types of equations. You are going to find a y-intercept, you just plug in 0 for the x. All right. So if I want to find the y-intercept of this first one right here on this next page, I'm going to say y equals 3 times 0 squared minus 2 times 0 plus 7. Oh. What's 0 squared? 0. So 3 times 0 would be 0. 2 times 0 would be 0 plus 7. So I would get 7. So my y-intercept for this one would be, sometimes you'll see it just given as y equals 0. A lot of times, though, you'll see it as coordinate points, so 0, 7. Because you plugged in x was 0, the y is 7. Okay, try these others. Okay, same thing, you're just going to plug in 0 for your x. You get 8 minus 0. Yeah. Which would just be f of x is written in y. Which would give you 8. Alright, now I'm seeing some of you not showing work on the end of them. Why? You don't really need to show work on these, right? What do you notice about, what do you notice is happening here, Isabella?
Any number that doesn't have a x, that's just going to be your answer. For example, number 4 is plus 3. It doesn't have an x, that's your answer.
Very good. Because what happens to all the terms that do have x's? They're 0, right? Because when you put a 0 there, it doesn't even matter what goes with it. You're going to get 0. Very good. So what you should be noticing here is that, like, for this problem, the 8 is the term that does not have the x. Here you got the negative 7. Here you got the positive 3. When you plug in these, we'll see what you guys did with that last one. Nothing to highlight on it. So like for this one, you're going to get 0, 8. And this one, you get 0, negative 7. And then here, you'll get 0, 3. For 5, you should get 0, negative 2. And then, oh, what do we get for 6? 0, 0. Yeah, it kind of looks like the 8s with x. So these should be your answers here. So when you're looking for the y-intercept, what you're doing is you're plugging in 0 for the x, but that causes it just to be the term that does not have an x value with it, right? Now, there could be, let me give you this right here, because there could be a problem. What if I have y equals 3 times x minus 5 squared plus 2? What if I have that one? Is 2 going to be my answer for that? Yeah, so this one, you're going to have 3 times 0 minus 5. You do actually have to plug the 0 in for this one because it's not given in that standard form where it's all multiplied out. So you would actually need to plug it in. You'll get 3 times negative 5 squared plus 2. This is going to be 3 times 25 plus 2. Go to those exponents first. That's 75 plus 2, so you'd get 77 for that. So it would be 0. 77. No. Yeah, negative times negative will be positive when you square that. Okay? Questions? So you may run across some that you have to plug in the 0 for, but if it's just in basic, like, standard polynomial form, it's just the term without the x. Okay, so let's think real quick about x-intercepts. Okay, x-intercepts are where we cross the x-axis. Okay, Aiden? Solving's going to be a little bit tougher. But you are correct. If I graph a parabola here, that my x-intercepts are going to be where my y is 0. So like this one would have 2 of them. You'd have 8, 0, and you'd have negative 5, 0. Right? So, to find an x-intercept, you're going to plug in 0 for the y-coordinate and solve. Now, these are going to be a little harder to solve than the y-intercepts. They're not terribly difficult, but the y-intercepts were super duper easy, right? So, for the x-intercepts, you are plugging in 0 for y, so that's going to give you 0 equals x squared minus 2x minus 3. Okay, what do we do to solve that? How are we going to put that x squared and that 2x together? We can't. So we don't want to move that plus 3. There is something we can do. What do you think, Aiden? Won't get. If you square root both sides right here, you have to square root this whole entire side. And the square root of 0 is 0, but this would make, it wouldn't get rid of just that square right there. It'd have all this stuff underneath square root, so it wouldn't get us anywhere. Alright. It is the most recent thing we've done. Quiz 8.1. If we had a quadratic equation, we can factor it. Okay, factoring. Yeah. Yeah. You're going to factor this. If you haven't, you may want to make yourself a note right there. So if you have an x squared and an x term, move to one side and factor. You actually in most cases, you're not going to have to worry about moving it to one side because you plugged in 0 for your y, so it's already equal to 0. So we're going to factor this. And we're going to work on our factoring a little bit more as we go through this, and we'll sort of review, because on our 8.1 quiz, some of you did really well. Some of you did not do so hot on that quiz, so solving these is going to sort of be built into the next stuff that we're doing. So if you were a little shaky on that, here's a chance to hopefully get a little better at it. So if I'm factoring this, I need an x and an x. I need numbers that will multiply to give me negative 3, which is just negative 1 and 3, or 1 and negative 3. Which one should I pick? Negative 3 and 1. Remember, those are not your answers. What have you got to do now? X minus 3 equals 0, and x plus 1 equals 0. So x here, you're going to add 3 to both sides. X is going to equal 3. And right here, you're going to subtract 1 from both sides. And so x will equal negative 1. So your x-intercepts are going to be at 3, 0, and negative 1, 0. Okay, everybody all right here? All right, let's look at the next problems. Okay, these problems ask us to find the x and the y-intercepts. So I'm going to do my y-intercept first because it is easy. So the y-intercept for these is going to be 0, negative 10. Right, if I plug in 0 for my x, I'm just going to get negative 10. Okay, x-intercept, a little tougher, because I'm going to have 0 equals x squared minus 9x minus 10. And just like the last problem, I've got an x squared and an x, so I've got to factor this. So, Caitlin, we'll have an x here and an x here. How's that going to factor? What? Okay, so for factoring, for our first term, we are looking for something that will multiply to give us x squared, which is just going to be x and x, right? For the last term, I'm looking for things that will multiply to give me negative 10. What are my options for that? Okay, negative 5 and 2. What else? Negative 2 and 5. What else? Negative 10 and 1. Negative 1 and 10. Okay. Okay. 10, I think, is probably going to be the case. We need our terms to give us negative 9 in the middle. So which one do you think we should try? Negative 10, positive 1. Because if I add those together, if I go back and check this, then those middle terms give me negative 10x. The inside terms give me a 1x. That gives me negative 9x, which is what I want. So remember, that's not our answer. That's just our factored form. To get your answer, if you do this last part in your head, it's fine with me. But you're doing x minus 10 equals 0 and x plus 1 equals 0. So here, that's just going to give you x equals 10. And over here, x equals negative 1. So our x-intercepts are going to be 10, 0, and negative 1, 0. Okay, try that next one on your own. Okay. So, let's see. Blakeland, what did you get for the y-intercept on this one? Perfect. Okay. And then for our x-intercept, that's a little bit more difficult. So we've got to do 0 equals 2x squared plus 13x plus 15. 2x and x, that sounds good. What have you got for the last part? Plus 3 here and plus 5 here. And if we check that to make sure it's right, that gives us 3x and 10x, which does give you the 13. So it's great. What have we got to do after that, Lanaya? Good. Good. Negative 3 over 2, because we're going to subtract that 3. So 2x equals negative 3. We're going to divide by 2. And x equals negative 3 halves. And then over here, you're just going to get that negative 5. So we would have negative 3 halves, 0, and negative 5, 0. Okay, I do want to tell one more thing about x-intercepts that we're not going to get into big right now. Most parabolas are going to have 2 x-intercepts. The ones that you run into, unless it's calculator active, are probably going to have 2 x-intercepts. I think. I can't, because you don't have to do quadratic formulas. So without a calculator, I don't know if you would, I don't think there's a way you would know. But it is possible for you to have parabolas that don't have 2 x-intercepts. I want you to see these. If I have something like x plus 3 squared, you may see some of these. Okay? Right here is my x-axis. How many times do I hit that x-axis? Just 1. You may see some of these. It's whenever you get something that's going to factor, like x plus 3 times x plus 3. What happens is you got kind of 2 x-intercepts, but they're in the same spot, so it's really only 1. So what you'll see is that maybe the parabola just comes down and barely touches the x-axis and goes back up, or it could come from below. So you may see some that look like this. What I don't think are going to see, unless it is calculator active, is, and I actually don't even think you're going to see it on calculator active, but there's maybe a chance. Yes. Let me just do it this way. I know I can make it. Don't worry about what this looks like. Is a problem like this. Okay. Is that one ever going to touch the x-axis? No. So some of them don't have any x-intercepts at all. I don't think you're going to see this a lot, other than maybe possibly asking you like something about the minimum point, but if so, it's going to be calculator active for that. Because these are going to have, this is where like imaginary solutions and stuff come in at like upper levels. So I don't think you're going to, we are not required to cover that here. But you could have no solutions at all. You could have one solution, one x-intercept, or you could have 2 for these. You'll never have more than 2. Also, one other thing here, we should go back here and do this, put this anywhere. Another word you're going to see used for x-intercept. Let's add these to our notes right here. X-intercepts are also sometimes called zeros, because it's where your y-coordinate is 0. So this word right here, you also might see used. All right, we're going to do one more part of these notes today, and then I'm going to give you your assignment to work on. Good news is this is also a this is just as easy as your y-intercept. Parabolas can open upwards or downwards. Sometimes I like to call the upward ones the smiley face parabolas. They're the happy parabolas. And the ones that open down are your sad face parabolas, right? So what affects this is your x squared term, because when you square something, it makes that number a lot bigger, right? So that term is going to affect whether or not it's mostly going up on the ends or going down on the ends. Because when you square big numbers, they are going to get big really fast, and it's not even going to matter what the other numbers are. So if the x squared term is positive, the parabola opens upward. If the x squared term is negative, the parabola opens downward. It does not matter what the other terms are. So if your x or your constant term are different, it doesn't matter. You only look at the x squared. So if I want to tell whether or not these open upward or downward, all I'm going to do is find the x squared term, and if it is positive, then it's going to be a smiley face parabola. So this one would be positive, so it's upward. Okay. If we look at number 2, I've got negative x squared. So my x squared is negative. So this would be sad face, downward. Okay. Anna Grace, what about number 3? Is that one going to open upward or downward? Down. So your x squared right here is negative. So that is downward. And let's see, Lexi, what about the last one? Up. Smiley face, upward. Okay. Questions so far? All right. So, because I could go on with these notes, but I think